All right, let's get started here. So I'm going to be looking at arcs and central angles. Oops. I want to open that with journal. Okay. And you need to open it twice for some inexplicable reason. Okay. So, name the arc made by the given angle. Now, I was taught that for arc notation, you name the 2 points on the circumference and you respect the order of the letters in the angle. So F to Q to E, depending on your convention, I was taught to go anti-clockwise, so this way, in which case it would refer to this huge major arc right there. However, within these problems, I believe that their convention under the hood is to go clockwise or to default to the sort of non-reflex angle specified by 3 letters. So I'll call this arc FE. And you do sort of a arc symbol above it, just like that. And I check, and that's correct. So what about the arc made by the angle 1? So I presume that's arc IH. And I check. Okay, so still going with their clockwise convention, it would be HI. Clockwise naming convention here, but anti-clockwise or counterclockwise on GeoGebra, for example. Name the central angle of the given arc. That would be angle 1. And for arc ML, that would be angle MQL. And we check, and that's correct. If an angle is given, name the arc it makes. If an arc is given, name its central angle. So we're given the arc RS. And following the clockwise convention, the name of that angle, that central angle, would be RQS. The major arc for angle 1. The major arc for angle 1. Well, now, major arc for angle 1? Wouldn't that be the other side of it, though? I'm unsure. I'll call it BA, going clockwise. But we'll see. Angle KQL, so that will be this acute angle there. And the arc for that will be arc KL. Arc SVT, SVT. Why did they give it those 3 letters? Oh, I see. Okay. So what they're talking about there for SVT is this. They name the arc using 3 letters, and that's their system of disambiguating between the minor and major arcs and being totally sure about what arc they're naming exactly. So if I were to do that up here, for example, the major arc for angle 1, I guess I would revise my statement and call it ACB, because I do presume that that is the major arc for angle 1. Now, they asked for the central angle for that. So I suppose it would be, if you go clockwise, it would be angle TQS. But if you go counterclockwise, if you name things counterclockwise, it would be the reverse. And we check. Okay, we're in agreement there. Here, ACB, okay, that's good, and KL, and they say SQT. So they seem to decide when they want to go clockwise or anti-clockwise, like almost at random, it seems. I guess I'll have to specify each and every time what it is that I'm actually doing. Okay, find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. Okay, so that angle there. Well, wouldn't that just simply be 120 degrees? And wouldn't this just simply be 123 degrees? We'll have to see. Okay, that's on track. Find the measure of arc CFD. All right, so that'll be going all the way around, like that. We have, well, we have access to the diameter, that's for sure. That is apparently a diameter, F to O to C, and thus we can say that this is 45 degrees. And also, because this is vertically opposite, we can say that that is 45 degrees. And so we must add these together and these together. 135 plus 81 is 216, and then add 90 and you get 306 degrees, I believe. Now find the measure of angle SPQ. The measure of angle SPQ. So if we go in this direction, again, this is why I believe that having explicit and dogmatic conventions is good, because I can't actually tell what angle they're talking about. But anyway, if we go clockwise, let's see what we can do. All right, so that's 86, that's 154, and that's 60. And therefore, we just have to think about what's left. So 86 at 154 is 240, and 60, that makes 300. And so these angles here together make 60 degrees. And then we go around this way. So we have 60 plus 86, which is 146 degrees. And we check. And okay, everything's correct. That's good. Find the measure of arc EFC. E, F, C. All right, so that's going around that way. So these, what are apparent diameters, are actual diameters, or so it's said. Now, these two angles are congruent, and therefore this must be congruent to them. In clearly, this trisects that 180 degrees, and this is 60 degrees. This is vertically opposite, so this must be 60 degrees as well. Then 120 plus 240 plus 126 is 246 degrees. And now find the measure of angle MIJ. MIJ. So going clockwise, as is apparently the case. Let's see. This arc, this angle here, which I would typically call KIJ, is 55 degrees. The measure of angle KIJ going counterclockwise is 55 degrees. The measure of angle MIL is 55 degrees as well, as it's vertically opposite. So 55 times 2 is 110. Take that from 360 and we get 250, and divide that by 2 and we get 125 degrees. And we check. Okay, so this is apparently not 234. How so? Let's see. Sorry, it's not 246. How so? So they say the measure of E to F to C. All right. Can't agree with that. I cannot agree with that, I'm afraid. Oh no! Look at that. Look at that. That's not true at all. Oh my goodness me. Wow. I'm really glad that I spotted that error. Okay. So 180 take 126 is 54. And this is properly vertically opposite. And these two angles are congruent. So it does not trisect it. That's an error. So now 108 plus 126 is 234, and that's right. Okay, that's all fixed. Now solve for x. Assume that lines which appear to be diameters are actual diameters. Okay, vertically opposite, that's 140. Sum is 280. Take that from 360, you get 80. Divided by 2, you get 40. So 6x minus 8 is equal to 40. So x is equal to 8. Now, this is x plus 93, so they say. This appears to be an actual diameter, so it's 180. Now, the remaining 180 is partitioned into well, this here would be 180 minus that. (180 minus that, which would be 87 plus x. I think x is simply 0. Unless it's saying that these two angles here are congruent. And then Can't quite tell with their unusual notation. If this signals congruence, then 2x plus 186 is 180. X is -3. But we'll see. All right, that's correct. Okay. Find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. Okay. Find the measure of WV. Okay. Right, that's the sort of question mark angle. And these are apparently equal. 5x plus 10. All right, and then we have this question mark angle over here as well, which is vertically opposite, so that's fine. Okay. Okay, so we can set up something here. So we can say that this is that, whereas this is that. And calculate now. $182 is 160 plus 2x, so 22 is equal to 2x, so x is 11. It seems. Find the measure of angle VST. Right there. Okay, and so these two angles are congruent. So -37x plus 2 minus 54x minus 6 is equal to 360. And now take these away. So -91x take 4 is 360. Add it on the other side and divide. And check. Oh no, you're supposed to find the measure of the angle, not just simply find out what x is. All right, fine. Okay, very quickly now. Find the measure of W of arc WV. So that's one. Okay, so 110 plus 20 is 130, and take that from 180, and we should get 50. And if I try that here, well, 11 times 12 is 132. No, that doesn't work. That's not correct. That's not correct. No, it is. 132 minus 2 is 130, and take that away, and that's 50. All right, fine. And here for VST, which is congruent to this, so just subbing in -4, we get -27 times -4, which is 108, and 108 take 3 is 105. And we check. And that's all correct. And that's good. Okay, now moving forward here into arcs and chords. Okay. How many? 14. Find the length of the segment indicated. Round your answer to the nearest tenth if necessary. Okay. But how to do this? Well, if you have a chord, doesn't a radius just simply bisect it? If I remember right. So I think x is 6, but we'll see. And here, of course, I also think that x is 3, but I'm prepared to be totally wrong. So I'll see. No, that's actually right. Okay, that's good. Okay, so I recall, and of course it does look like that as well. So the 7.1 and 3.2 aren't really relevant. So anyhow, now let's see what's up. So they say find x. Well, we're told the diameter, I think that's what they're saying, is 31.8. And this here would be a radius, would it not? So 31.8 divided by 2, first of all, is 15.9. And then subtract 7, and we get 8.9. Okay, here. Well, the radius appears to be 9.7, and this length here appears to be 5.1. So 9.7 minus 5.1 is 4.6. And we'll check at each step of the way. Okay, these are valid. Okay, next. The diameter is 25.2. So the radius is half that, which is 12.6. And then we subtract 4.5 from 12.6 to get 8.1. The diameter is 18.8. Half that is 9.4. Then subtract this 4.2 from 9.4, and you get 5.2. And that should be what x is. And we check, and that's correct, and that's good. Okay, so we have to find out what x is. They appear to just be directly telling us, in this case, the radius is 4.3 and x is a radius. So we're just going to say 4.3. Likewise here, they seem to just be directly telling us that the radius is 4.4. So we'll just say 4.4. And we check. And not quite. So they say this is 11.4. So what is this 4.3 referring to then? So there's ambiguity here. So it appears that this 4.3 actually refers to this. And they want this. The 10.6 refers to that, it seems. Okay. Okay, so the Pythagorean theorem in this case. So half of 10.6 is 5.3. So x should be the root of 5.3 squared, add 4.3 squared. And so we'll check that out now. $6.8. Okay, we check. Okay, so that's still not in agreement. That's still not right. I can't quite tell why. I really hope they're not calling this 10.6. That would be, I mean, they could be because it's all the way over here, right? Whereas usually the label would be here if it was referring to the entire chord. So we'll try. We'll try doing that. And that's how we get the right figure, the right answer. So, okay. 11.4 based on that now. But we have to correct our notes. Okay. Now, in this case, being more careful, 4.4, I'm pretty sure refers to that. 8.3, I'm pretty sure refers to that. And these are congruent. All right, so let's try it out. 4.4 squared plus 8.3 squared, and we get 9.4. And we check, and that's correct, and that's good. Okay. 8.4, I'm almost sure it refers to this leg of the right triangle here, whereas 10.4, although a radius also refers to the hypotenuse of this right triangle. So square root of 10.4 squared minus 8.4 squared, that should get us x. And we get 6.1 to the nearest 10th. Here, there's ambiguity, but okay, I think 10.8 refers to this length here, and 12.5 refers to this length here. So, although it may not look it, this radius would bisect this chord, and therefore this would be 10.8. And so x would be the root of 12.5 squared minus 10.8 squared. Which is 6.3. So we'll check these two. And they're correct. And that's good. Okay, here 16.7 is the radius. 15 is half of the chord here. So there would be another radius right there. And using that, we could obtain this length y. And then we'll subtract that from the radius to obtain x. So in total, or in full rather, the calculation is 16.7 minus the square root of 16.7 squared minus 15 squared. So we do that now. 0.7 squared minus 15 squared. And we get 9.4 to the nearest tenth. Okay, here 15.1 is the radius. 12.8 is half this chord. So it's pretty much the same situation. That would be 15.1. And so 15.1 minus the square root of 15.1 squared minus 12.8 squared. Just like that. And we get 7.1 to the nearest tenth. And we check. And these are correct. Okay, because of where 30 is positioned, that appears to be the length of the diameter. So the radius will be 15. And so 14.1 for this other half of the chord here, 15 for the hypotenuse of this right angled triangle here, and then we obtain what is called y there, and then we'll take that away from the length of the radius. So we're going to do 15, which is the radius's length, minus the square root of 15 squared minus 14.1 squared. Just like that. Okay, and we get 9.9 to the nearest tenth. Okay, last one. 15.7 appears to refer to this half of the chord. So that'll be 15.7 as well. And the radius is 18.9. So it's a similar situation to before. 18.9 now minus the square root of 18.9 squared minus 15.7 squared. So 18.9.7, and we obtain 8.4. And we check to see if that's correct. And it's all correct. And that's good. Okay, next we'll look at circumference and area of circles, circumferences and areas of circles. And how much is there here to do, or how many rather? Round about 27. So find the area of each, use your calculator's value of pi, and round your answer to the nearest tenth. So I'm going to give answers in quote unquote exact values. This calculator is so dodgy. Oh, there it is. It's alive. Okay. The area will be pi r squared. In this case, pi r is 12, so it'll be 144 pi exactly. Which is, to the nearest tenth, 452.4 square inches. Here, it'll be 196 pi. Which is 14 squared. To the nearest tenth, that'll be 615.8 square kilometers. Next up, 9 squared is 81 pi. Which is 254.5 square meters to the nearest tenth. 11 squared is 121. Pi, which is 380.1 square centimeters to the nearest tenth. And now, no picture present. Square 2.6 to get 6.76 pi. And that is 21.2 square inches. Square 34.1 now. 34 squared is 1,156, and 34.1 squared is 1,162.81. And we obtain 3,653.1 square inches. 13.2 squared. 13 squared is 169. 13.2 squared is 174.24. So here we go. which is, when multiplied by pi, 547.4 square kilometers. And now 29 squared is 841, and 29.9 squared, well, think of it as 300 squared, which is 90,000, and then take away 300 to get 89,700, and then take away 299 to get 89,401, which when we adjust is 894.01. Okay, so let's try it. (2808.6) square kilometers. Now we must find the circumference of each circle and round our answers to the nearest tenth. So the circumference of a circle is pi multiplied by its diameter. In this case, the diameter is 8 miles, which when we double it, the diameter is 16 miles from doubling the 8-mile radius. 25.12, and what's double that? 50.24. Okay, so it'd be, but then next door to that will be the result of multiplying that 1/5. So it'll be in excess. So it should be 50.3, I think. Now 8.3 yards, which is, when doubled, 16.8. So we get 52.8 yards. 8.4 pi is 26.4, so 26.4 yards. 12.6 pi is 39.6, so 39.6 miles. That's the circumference of this circle. And now we're just told that the radius is 5.2 feet. So see if you can obtain the circumference from that. Well, if the radius is 5.2 feet, the diameter will be 10.4 feet. So 10.4 times pi is 32.7. Here, 22.2 times pi, which is 69.7 feet. And here, 19 times pi, which is 59.7 inches. And 18.6 rather, which gives 58.4 inches. Now find the radius of each circle using the calculator's value for pi. So if we're told the circumference, and the circumference is pi multiplied by the diameter, then the radius, we can obtain it from the circumference by dividing it by pi and then dividing that by 2. So in other words, divide it by 2 pi. 62.8 divided by 2 pi gives, to the nearest tenth, 10 miles. That would be the radius of this circle. 69.1 will be nearly the same, but it's 11 yards. And then 12.6 gives 2 yards. 25.1 gives 4 feet. Find the diameter of each circle. We know that the area is squared. So we can rearrange this to get what the radius is, and then double it to get the diameter. Dividing both sides by pi, and then finding the square root of both sides, we obtain this. So the area here is 201.1, and we must divide that by pi, and then we must find the square root of the whole answer. And then double that and round to the nearest tenth. So it would be 16 inches. Here, just put in 78.5. So I'm going to use Wolfram Alpha because the calculator is not working. And we obtain 10. 10 feet is the diameter. Now find the circumference of each circle upon being told the area. If the area is pi r squared and the circumference is pi, how to obtain the circumference when we are given the area? Well, from above, the radius is the square root of the area divided by pi. Then that just needs to be doubled and multiplied by pi. So it would be 2 pi times the square root of a over pi. Okay, so calculator is back now. The area in this case is 64 pi, and then we divide that by pi, and we obtain that the circumference is 16 pi, which to the nearest tenth is 50.3 miles. Making an appropriate substitution here, we get 8 pi, which to the nearest tenth is 25.1 inches in this case. And now to find the area of each upon being told the circumference. So, if we're told the circumference, we want to turn that into the radius. So divide it by pi, and then divide it by 2. So c over 2 pi, that will give you the radius. And then square that and multiply that by pi, and that will give you the area. But when you think about it, that would be pi times c squared over 4 pi squared. The pi on the top and bottom cancel out. So it would be c squared over 4 pi, like that. In this case, the circumference is 6 pi. So we square that and we get 36 pi squared. Then we divide that by 4 pi and we get 9 pi. So that should be the area, which is approximately 28.3 square yards. Here, the circumference is 22 pi. So square that and we get 484 pi squared. And divide that by 4 and we get 121 pi. Which to the nearest tenth is 380.1 square inches. Now find the radius of a circle so that its area and circumference have the same value. Okay, so let's see. We know that A equals pi r squared and C equals pi d, which if we write it in terms of r is 2 pi r. So now set them equal to each other. So pi r squared equals 2 pi r. And we can cancel pi on both sides. So we get r squared equals 2r. And then cancel r on both sides. So we get r equals 2. All right, so let's check everything involved. Checking everything. Okay, that's all correct. That's all correct. Uh-oh. What was going on here? Not sure. Perhaps I entered value slightly wrong. I want to know. We double that, we get 16.6. And then multiply that by pi. And we get 52.2. So I'm perplexed. No, I must have simply wrote it down incorrectly. That's all. Okay, that's all correct. That should be 39. That's correct. Okay, they've given the answer in pi, which is not okay, but all right, whatever. Okay, that's all good. That's all good. What will come next? Maybe some calculus. Be well, be well.